Hello everyone, my name is Michael and today I want to talk about devs love CICD, efficient second ops pipelines. And before we dive into it, I'm a developer evangelist at GitLab. You can find me online as DNS Michi, which is DNS M-I-C-H-I, and Michi is the lovely form of Michael in German. And without further ado, I want to step into what's coming in the next round about 20 minutes. So we are looking into CICD and how this relates to DevSecOps, then learning how to dive into a pipeline, being deep down, defining team actions, looking a little bit into security, and then into automation and iteration on DevOps. Now, when we start building things and we add CI/CD to our workflows, it's oftentimes why do I want to do that? And sometimes you have an idea and you see a competitor having the same idea, and how fast can you deliver? How fast can you release software? So in the end, it's a matter of efficiency and speed, and releasing faster than everyone else, and bringing something to the market which enables you to benefit from that. That being said, starting with CI/CD is oftentimes a long process, and you're adding it, everyone is adding it, and then sometimes there's lots of trial and error involved. On the right hand side, there's an example with GitLab, but you can totally map it into a tool of your choice. The thing is, we want to overcome this, and there are other problems which you can encounter and say, hey, the pipeline runtime is way too long, so I'm not getting any feedback, and the reviews are being blocked because I need to wait 10 minutes or something like that. And on the right hand side, well, there's an example for that which I saw lately, and said, well, a typo was actually the root cause for like 6 minutes, 5 minutes delay, and you actually need to fix that. So as a developer, I need to become ops at a certain point, and someone says, please fix the CI/CD pipeline. I said, why? Yeah, because they consume so many resources. And then I'm like, how? Yeah, read the docs. Hopefully someone in the community can help. Maybe someone wrote docs already or something like that. And then this is the thing, you're asking yourself, well, what's actually inside the pipeline? What's there? How can I work with that? And oftentimes it's identifying the pipeline runtime duration on its own and seeing, well, what is the critical path? What is the minimum and the maximum pipeline duration? Identify the number of steps, like stages and jobs or whatever it is called in your workflows. Identify how long they are taking and which one could be a blocker. Like all jobs are taking 5 seconds, but there is one with 7 minutes for some reason. Another thing to look into is when you have sync runs, there might be dependencies in the middle blocking it. Like when you're manufacturing a car and the left door is not being pulled into, you have a problem. Then another thing to identify is a pattern with failed tests. So it's not just this one pipeline which failed, it's a trend over time. So you might have flaky unit tests, like sometimes they're okay, sometimes they are not okay, depending on the date and time, or specific influences from a network outage or something else. Another indicator is when the test coverage drops for some reason and it goes down, down, down. So you really want to dig into that. There is a lot more to that, and saying, hey, my environment is built upon Node.js or C++, and then I have built dependencies, and they need to be installed every time the CI/CD pipeline is being run. You need to work with containers, probably. There is a certain network latency involved, and at a certain point, security might also be preventing something, or there's a problem within your pipeline. So these are all things you need to be aware of. And the first thing I would recommend to start looking at is if you have a certain CICD analytics overview dashboard, something like which tells you about the pipeline duration, about failure and success, allows you to see some beautiful graphs, whether to identify there is a pattern. So like, is the pipeline duration 7 minutes all the time, or is it just like 8 a.m. in the morning and then everything is fine, and then you can correlate it and ask, for example, the SREs or the ops team and say, hey, is there something in the Grafana graphs? And you should probably ignore spikes and anomalies because they don't tell you anything. So really look for specific patterns which give you an insight which job or where to look next. Then, in case you have unit tests, and I hope you have them, look into the CI step and say, hey, is there something which can provide me further insights? Is this like an ongoing problem which is like moved from the job to the next job and so on? You can also generate the test coverage and in order to monitor that. And for example, with GitLab, you can use a JUnit integration. There are other tools out there, so it's not like written down in stone, but still, it's a good way to get more insights into the pipeline and into the actual workflows. The other thing I would recommend too is like explore the visualization layer. So looking into logs and analyzing job duration can be like, you need some sort of like visualization and seeing the critical path, meaning to say there could be a different representation of the pipeline because the image at the top just shows the stages and the jobs. But if there are asynchronous dependencies inside, so meaning to say the former job triggers the unit test, triggers the compile job, and then the run, this is like the critical path in the pipeline. So and everything else, like generating a test report, is not so important. Identifying bottlenecks can also be helped with visualization, but also needs the right visualization layer, and not just like saying, hey, I really have a hard time looking at it and I cannot really figure it out. Now, this is like the high level, and we want to dive a little more deep down into a pipeline, what's actually going on and which things we potentially could influence. So how can I get more efficient in a pipeline? I need to check the workloads. Probably. So how many compute resources are being used in the pipeline in the specific jobs? Are there any specific bottlenecks I can see really like from just looking at the duration? I also want to look into the resources being assigned to it, like draining the CPU or using lots of memory could be a factor you want to dive into, especially when it's tied to cloud compute costs in that regard. And you totally want to really see the global picture. So if something else is influencing the pipeline runtime or like the resources being drained for some reason, because there is a deadlock in the software and you didn't really discover it yet because there's no runtime monitoring. When you have found the flow or you have understood the flow, discuss the actions with your team, like refactor the pipelines. Basically, everything is YAML today. You can treat the pipeline as code and start refactoring the code. You also want to reduce the cost and also reduce the computing powers needed, especially because compute powers are not for free. You need to pay for them. So in a specific environment or scenario, you could potentially save a lot of money by reducing it. Now, how can I visualize that? Well, there are probably things within the tools that you can use, but from a monitoring or observability perspective, it also makes sense to approach it from the outside. So given I want to, for example, monitor GitLab CICD pipeline health, and I want to still use my existing monitoring environment, which is based on Prometheus and Grafana, I can, for example, use a Prometheus exporter which queries the REST API and then collects all the data, and Grafana has nice, beautiful dashboards for that reason. If I would be using Zabbix, Nagios, Izinga, Sensor, whatever is out there as a monitoring tool, I could use a check plugin to integrate that. And there's potentially even more than that, so it's not really bound to the tools. The thing is, you want to have something visualized in your operations dashboard and immediately see when the pipeline duration is going off, and even being alerted. And last but not least, seeing trends and spikes. The thing is, the pipeline on its own is like a black box to monitor. You also want to dive deeper and say, hey, I want to monitor the storage consumption, like disk usage. Maybe expiring the artifacts if there are some for the jobs. The container registry images normally consume lots of space depending on how big and small they are created. Network traffic comes into play. So the CICD jobs installs software on every run. This is being pulled. Similar to huge Docker images being pulled, this generates lots of network traffic. The other thing is, if you're having an external CICD runner, which is running in your EC2 instance, for example, disk I/O, CPU usage, basic Linux, Windows, Mac OS host monitoring. And last but not least, everything the application itself consumes can be monitored in a certain way of saying, hey, I want to integrate the APM metrics collected in the CI/CD jobs and have them integrated into the merge request or pull request widgets. So there's lots of things to unpack and to learn from. It's important to measure them to get a better overview of what's going on. And inside a merge request or a pull request, we also want to have fast feedback. So we want to see the test coverage as a visualization layer. We want to see metrics and unit test reports and code quality and accessibility testing and security testing. Basically everything we have already provided or at hand or which can be integrated should be visible. And when someone is working in a feature branch or in a branch technically, they should get feedback immediately and not merge something which is either broken in a security way or in a secure way, or also by preventing to publish something where the performance would be 5 times slower than before, just because of a problem in the algorithm detected by the application performance monitor. Now, you can also use batches in the project, making it like allowing it for faster detection of the current pipeline status, of the test coverage reports, and so on. So there's a couple of ways in the README-MD or directly in the project. After you have defined or identified the bottlenecks, you also want to define the team actions, which means one of the patterns to go there is say, hey, I want to fail fast. Because in that example, the format and the unit test jobs already failed because there was a typo in the code, but the code quality check is still running because it runs all the time in the same stage. Now, the solution to that is to say, I want to fail fast and the format job runs before anything else is being triggered. And when it fails, the pipeline fails and we are good to go. Well, not good to go, but we are saving resources and get immediate feedback. The other thing is we want to optimize the CI/CD infrastructure where everything is being run. So when Docker pull takes too long or is rate limited since last year, we probably want to use our own container registry or use a specific container registry available, or GitLab, GitHub, whatever is being in use. And we also probably want to optimize the CI jobs which always install the dependencies and create custom Docker images which have the build tools available by default. And another thing to keep in mind is whenever things are being pulled or installed, keeping cache layers for node modules and everything else, like reducing the overall cost and time where CI/CD jobs are being run. Now, as a team action, we also need to learn how to fix pipelines fast. So it shouldn't be the case that only a single person is the DRI, the responsible person for fixing the pipelines. We all should be able to do it on our team. So everyone should understand the failures quickly, and the CI/CD job output needs to use the key messages, something which is easy to follow, and say, hey, in this line you made a mistake, and there is an error and not a stack trace over 2 pages. We can also use colored error messages on the terminal, and also use emojis as a Unicode or UTF-8 encoded character. We can also link things in there, like troubleshooting documentation or documentation how the pipeline is designed. Since we are probably using Git repositories all the time, we can also document the pipeline design in there as a markdown format or something else. An example could be using Mermet, which is available at least in the GitLab markdown, but potentially Draw.io or something else is also possible. And whenever you fix something, document the way you learned how to fix it. Sometimes the Google terms you have been using, the URLs you have been reading, the blog posts which brought you to the solution. Because in the end, half a year later on, someone else can benefit, or you, since you run into the same problem and you don't need to research 2 days to fix something. Now, coming a little bit into security, like, can we release the source code to our customers, to contractors, to the public domain? So, okay, let's just do it. And then we are leaking the AWS credentials from the test suite. Need to roll over everything, revoke something, and it's 3 a.m. in the morning, and everyone is running into burnout. This is something we also want to prevent when looking into efficient CI/CD pipelines. The other thing is, credentials can also be like in the CI/CD config. So the MySQL password is like has root access, and this is actually the production environment. And yeah, it's not really a good idea to leak it on the internet. Still, again, now it involves DevSecOps. Monitoring is red, everyone is busy, and humans make mistakes. And how can we prevent that? The thing is, there are certain ways, and I mentioned that before, we can have the feedback immediately from security scanning and merge requests and pull requests. And in order to solve the runtime requirement for the production MySQL database, for example, we have the possibility to leverage things like HashiCorp Vault, where we just get a secret as a token, which is limited in time, and then everything works. And this is not only tied to CI/CD, but actually to production usage as well. Now, we also want to ship things faster. This is like the CD part of everything. So developers want to deploy everything fast, like building things automatically, installing all the dependencies, testing things, tracing things, scanning, fixing, suggesting, deploying, merging. Yeah, maybe merging. I'm not sure about this. So one of the ideas we want to do that with Cloud Native in a 5-minute production app. This is something which is currently in development. On the other side, we also want to look into what's already there, so fast versus resources. We have the possibility to use some sort of auto-scaling and saying, hey, 9 to 5 developers need the fast builds, but on the weekend there are not so many resources assigned to our CI/CD pipelines, reducing the compute cost being acquired all the time by virtual machines being run. There are specific environments which can be used, like virtual machines with Docker machine, the hyperclouds like AWS, GCP, Azure, and their APIs, OpenStack, and probably I've missed many other managed clouds. For Kubernetes, we can use the runners and look into Node Affinity. Now, are developers still in love with CI/CD? Yeah, probably, because lots of things have changed. The UX is getting more interactive. We have quick actions. People start using or creating a CI/CD pipeline editor. The the learning curve is getting more easy, and we're also getting fast feedback because we optimize a lot, and many of the things I talked about today are already within the pipelines, or they are available hopefully soon, or people have started applying them. Now, another thing is we can automate so many things. So if we want to do config linting, we have API endpoints, we have security left shifted, we have CICD templates which everyone can use, and last but not least, we also have quality gates in our continuous delivery process. So meaning to say we are defining our SLOs, our service level objectives, and saying, well, if that is not met and the memory consumption increases, we're not letting the deployment go on. And in addition to that, we also add application performance monitoring and more observability to our pipelines. So as a developer, I can really benefit from that. And I think everyone is still in love with CICD because we have our Grafana dashboards for ops, we have security dashboards for SEC, we have all the details in the MRs and PRs for our devs, and everyone has gotten more pipeline insights. And this is not bound to GitLab on the right-hand side. I've also seen that with GitHub, with Circle CI, with many other different toolings which are available, and I think everyone inspires everyone to make it easy for developers. So with that being said, I will share the slides and the recording, of course, later on. Thanks for your attention, and I'm looking forward to your questions now.